Hello, I am Ravish Suknandan, and on behalf of my co-authors Yanshin Lee, Dr. Jeffrey Gill, Professor Hillel Chiel, Professor Victoria Webster Wood, and Professor Roger Quinn, we are presenting our work on a bio-inspired synthetic nervous system controller for pick-and-place manipulation. Animals are capable of remarkable behavioral diversity, which includes locomotion and object manipulation. The SNS, which stands for a synthetic nervous system, is a bio-inspired approach to neural networks that incorporates elements of real neural dynamics. SNS approaches have previously been used to control locomotion in legged robots but require tuning of many parameters, which can be done manually or via optimization. In this work, we hypothesize that supervised learning techniques can be used to train the SNS to perform arithmetic operations such as subtraction and multiplication, eliminating the need to manually tune the network parameters, and that the SNS can be used for real-time control of a grasper robot for a pick-and-place manipulation task. For more involved arithmetic operations like division, the SNS exhibits superior performance to artificial neural networks, ANNs, as it is both more accurate and requires less training time. The same holds true for multiplication. We can then assemble these SNS subnetworks capable of arithmetic operations into a hierarchical controller for the control of a grasper robot for pick and place. The controller takes as input the positions of the object, gripper, and the target, as well as the contact force between the object and the grasper. This information is then sent to the command neuron layer, which is divided into the 8 major sequences that the grasper robot must follow. The motor neuron layer then sends the low-level joint commands to the robotic grasper. Here, the plant is a simulation of the grasper robot developed in PyBullet in order to test the SNS prior to deployment in a real system. Sensory feedback from the simulation is then given to the sensory neuron layer. Using the same SNS controller tuned in the simulation environment, the real grasper robot can be controlled to execute the pick-and-place task without further tuning of the controller. On the real-time SNS control, the robot moves to the object, slows down as it approaches the object, grasps the object, lifts it off the platform, moves towards the target, slows down as it approaches the target, releases the object, and finally retracts and moves towards the home position. In conclusion, we show that the SNS has improved learning time and accuracy for division and multiplication operations compared to compact ANNs. The SNS can be used to create a controller for manipulation tasks, and that the SNS controller tuned in simulation can be used in the real grasper robot without additional tuning, and that they exhibit similar behavior and kinematics. Future work will validate the SNS on robots with more complex dynamics and implement plasticity for adaptable grasper behavior.